Well, for example, if you have x plus y to the second power, you would multiply x plus y times another x plus y, and then you would end up getting s squared plus 2xy plus y squared. But what if you had x plus y to the third power? Well, that means you're going to have x plus y times x plus y times x plus y. And when you multiply all these together, multiply these two together, and then take the answer, multiply by that, which means multiplying this by another x plus y, you're going to end up getting, x to the third plus 3x squared y plus 3xy squared plus y to the third. Okay, so what about if you take x plus y, raise it to the fourth power? Well, that means I got to take this whole thing right here, and I got to multiply that by another x plus y. And when I do that, I'm going to get x to the fourth plus 4x to the third y plus 6x to the second y to the second plus 4x y to the third and plus y to the fourth. Okay, so if we keep going, then what about if I multiply this by another x plus y? That means, what if I have that? Well, that means I got to take this whole thing here and then use distributive property and multiply that thing by x plus y. Okay, well, what do you get when you do that? Well, that's not that hard. You're going to get x to the fifth plus 5x to the fourth y plus 10x to the third y to the second plus 10x to the second y to the third plus 5x y to the fourth and then plus y to the fifth. Okay, and then you keep going like that. Well, how am I getting these answers so fast? Well, first of all, I just need to know what the coefficients are. Okay, and that's what Pascal's triangle does. So when you have x plus y to the 0 power, we know all of that is going to be 1, because regardless of what you raise to a 0 power, it always turns out to be 1. But what about it? You have x plus y to the first power. Well, the coefficient, that's what I'm looking for, is 1 and 1. And if I take x plus y raised to the second power, the coefficients of this is going to be 1, 2, 1. Okay, how am I getting those numbers? Okay, and we're going to talk about the x's and the y's in a second. So here's a little trick. When I raise x plus y to the third, my first term's always going to be 1. To get this, I just look up and add the one previous to that, which is going to give me 3. And to get this number, I'm going to look up and add the previous one to that, get 3. And then the last one is always 1. Okay, and then let's do a couple more. Let's say I have x plus y to the fourth power. First coefficient's 1. And the next one's going to be, I'm going to looking up, and I'll add the one before that, which is going to give me 4. And then to find, I'm going to look up, add the one before that, which is going to give me 6 here. Look up, add the one before that, which is going to give me 4, and the last one's going to be 1. Now, if you notice, fourth power will have 4 as a coefficient in the second term, and then 4 is the next to the last term. You also notice when you have a fourth power, you have 1, 2, 3, 4, 5 terms. Okay, and then the middle one is unique, and then these two basically repeat on the other side. Now, if you have an odd power, okay, the middle two terms, okay, the second term is 3 because it's the third power, and then you're going to have even number of terms, okay, 2 on each side, and then they're going to go up and then come back down. Alright, so having said all that, let's go x plus y to the fifth power. Well, that's going to be 1, and then next one's going to be 5, next one's going to be 10, and next one's going to be 10 again. Okay, and then I'm going to repeat again, go down 5 and 1. Okay, since that's a fifth power, I have 3 on one side, 3 on the other side, and I get a little pyramid. Okay, 1, 5, 10, 10, 5, 1. Okay, How about one more? Okay, how about x plus y to the 6th power? Well, it'll be 1, 6, and then next one's going to be 15, and then 20, and then 15, and then 6, and 1. Okay, how are these numbers going to help me? Well, if I want to raise x plus y to the 6th power, and let's do that, it's not that hard. X plus y to the 6th power. My first coefficient is 1. Okay, and then my power on the x is going to be to the 6th. Plus. The second coefficient is going to be 6. Okay, and the power on the x goes down by 1, so it becomes 5. And the power on the y goes up by 1, so it's down positive 1. And then, plus. The next coefficient is 15. Okay, 15. The x power goes down, so it becomes 4. And the y power now becomes 2. Plus. Next one's going to be 20. So I have a 20. And then x is to the power of 3. And y is to the power of 3. Notice x is going down and y is coming up. Plus 15. Okay, because that's my next coefficient. And then x is to the 2nd and y is to the 4th. Notice these two add up to 6. These two add up to 6. These two add up to 6. All the powers always have to add up to 6 on the 6th when I raise a binomial to the 6th power. Okay, plus. Okay, we've got two more terms, so we've got 6. And then x is to the power of 1 and y is to the power of 5. Because they have to add up to 6 now. And then the last one's going to be y is to the 6th. And there it is. Okay, that's how you expand a binomial using a Pascal's triangle. And this here is known as the Pascal's triangle. Okay? Alright, let's do some problems dealing with Pascal's triangle. Let's go to problem number 3 on the worksheet. So make sure you print this worksheet out for Monday's class. Problem number 3, it says they want me to find the 4th term. Okay, and that's what I'm finding on this expansion, 3a plus 1 to the 3rd power. Okay, I'm raising it to a 3rd power, so let's go ahead and do our little Pascal's triangle. That's 1, 1, 1, 1, 2, oops, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, and then let's go one more. 1, 5, 10, 10, 5, 1. Okay, those are my coefficients of the Pascal's triangle. Alright, so this is a 3rd power, so we're looking at those coefficients right there. Okay, so what we're going to have is 3a acts as the x and 1 acts as the y. So 3a, whenever you have more than one value there, so put parentheses around that. 3a is to the 3rd. Okay, that's that term, plus, and then I have a 3a 3 times. Let me go back here real quick here. Put the coefficient in first. 3, that's my 3, times 3a to the 2nd, okay, times 1, plus. The next coefficient is 3, so 3, and then I have a 3a to the 1st, and then have 1 to the 2nd. And then the last one's going to be 1 to the 3rd. Okay, we have to clean this up. 3a to the 3rd, 3 times 3 times 3, which is 27a to the 3rd, plus 3 to the 2nd, which is 9. 9 times 3 is just 27a to the 2nd times 1. Okay, plus 3 times 3 is 9a, and then times 1, and then plus 1 to the 3rd is 1, and that is the expansion. So, what is the 4th term? Well, that's the 1st term, 2nd term, 3rd term, 4th term. And there it is. That's the 4th term. Now, that's a long way of doing it, so let me show you a shortcut. Okay? How do you find the 4th term? Okay? So, let's do problem Let's do problem number 4. Okay. And you have a second, we're finding a second term, okay, and without expanding all of this, okay, and then I have a x minus 3y to the 4th. Okay, so 4th power means, I'm going to be using those coefficients. Okay, we're looking at the second term. That means it's going to have 4 as my coefficient. So that is going to be 4. Okay, that's my second term. It's going to have 4 in the middle. Now, what about the x and the y's? Okay, so now on the second term, okay, the power on the y, this one will always have 1 less. So that'll be negative 3y to the power of 1. And then, remember, this is always have to add up to 4, so that means x is going to be the power of 3. So if you clean this up, that'll be negative 12 x to the 3rd y, and that is the second term of that binomial expansion. Or you can also call that binomial series. Okay, so let's go to 10. In number 10, they're asking for the third term, okay, of this binomial x plus 4 to the 4th. Okay, so again, I need to what coefficients are. So it'll be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, so we got what we need. There it is. That's my Pascal's triangle. All right. So third term, which is 1, 2, 3, will have a coefficient of 6. Okay, and then x, I'll have an x, and then this is 4. Okay, and then I have 4 to some power. Well, on the third term, the 4 will be to the power of 2. That means this is it has to be a power of 2 also. Okay, so that's basically, you got 6 times 16. Okay, so 6 times 16, 6 times 16, which is 96. So you have a 96x to the second, and that's the final answer. Alright, let's do a few more problems, and then we'll be done. So let's go to number 13. You have a minus b, and they want us to raise this to the 6th power. Okay, and we're going to use Pascal's triangle, and then tomorrow I'm going to show you another way of doing it called binomial expansion. Alright, so we need 6th power. That means we need coefficients. Go 1, 1, 1. Okay, let me have a little more space here. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. That's 4th power. So 5th power is 1, 5, 10, 10, 5, 1. And 6th power is going to be 1, 6, 15, 20, 15, 6, and 1. Okay, those are my coefficients. So they just want me to expand this. So that means this expands to a to the 6th first. So I have a to the 6th. And my coefficient is 1, so I don't have to write that. And then I have a plus, and then I have a 6 as my coefficient, and a is to the 5th, and negative b. Okay, it's got to be negative b. It's not positive b this time. This to the 1st. Okay, and then plus. The next coefficient is 15 because I'm using these coefficients right there. Okay, and then a is to the 4th, and then negative b is to the 2nd. And then plus. And then the next coefficient is 20, and then a is to the 3rd, and negative b is to the 3rd. They have to add up to 6 in this right now. Okay, and then plus. Okay, the next one is 15, and a is to the 2nd, and negative b is to the 4th. And then I have a plus 6, and then a is to the 1st, and then I have a negative b is to the 5th. And the last one's going to be negative b to the 6th. Alright, we need to clean up just a little bit, okay? And I want you to notice something. Now, usually we had a plus in the middle, okay? But we have minus, so we're going to go ahead and take the minus with the second term. And let's see what happens. The final answer is going to be a to the sixth. Since that's going to be negative, my answer is going to be negative 6a to the fifth b. But this negative is getting squared, so that'll be positive 15a to the fourth b to the second. And this is negative, and we're cubing it, so we're going to get a negative answer. Negative 20a to the third b to the third. And then negative b is going to be raised to the fourth power, that means it's going to be positive 15a to the second b to the fourth. And then this is going to, negative b is going to be to the fifth power, that means it's going to be negative 6ab to the fifth. And then negative b is going to be raised to the sixth power, is going to be positive b to the sixth. Okay, I want you to notice something. Whenever you have a minus in the middle, okay, you can do what I did, which is fine, or you notice that it alternates. First term is plus, second term is second, minus. Third is plus, fourth term is minus. Fifth term is plus, sixth term is minus. Okay, so on and so forth. It alternates plus, minus, plus, minus, plus, minus, plus, minus. Okay? And that is the expansion. Let's see. Oh, need to do one more. Yeah, let me do one more. Okay, just in case. If you don't get it yet. Let's do 27. Okay, and we're going to work on 1 through 30 Monday in class. So this is 3x to the fourth, okay, minus y to the fifth. Y to the fifth. Okay, so we need a Pascal's triangle, at least for today. Okay, got 1, 1, 1, 1, 2, 1. That's the second power. So the third power is going to be 1, 3, 3, 1. Okay, and the fourth power is going to be 1, 4, 6, 4, 1. And fifth power is going to be 1, 5, 10, 10, 5, 1. Okay, we got our coefficients. So we're just going to fill them in. Okay, so I'm going to have 3x to the fourth raised to the fifth, and the coefficient is going to be 1. I don't have to write that 1 in the front. Okay, and this is minus, so I'm just going to go ahead and take care of that right now, because I know from the last problem they alternate, so that means the second term is going to be minus. I'm going to go ahead and put the minus, and you can do it either way, it's fine. You can leave the minus with the y, okay, or just take it out and start alternating. Okay, the coefficient is 5, and there's my 5. Okay, and then I'm going to have a 3x to the fourth is going to be to the fourth, and then y is to the first, plus. Okay, then I'm going, next coefficient is 10. Okay, 10, and I have a 3x to the fourth is going to be to the third, and y is to the second. And then next one's going to be minus, because I have to alternate the signs. Coefficient is 10. Okay, and my first term is going to be 3x to the fourth. Now it goes down by 1, so that becomes 2. The power becomes 2, and then y has a power of 3, because they always have to add up to 5 in this problem. And then next one's going to be plus, and that's my 5 coefficient. And then I have a 3x to the fourth is to the first, and then y is to the fourth. Okay, and then finally it's going to be minus. Okay, and that is going to be y is to the fifth. Alright, the rest of it is just cleaning up, raising 3 to the fourth power, multiplying by negative 5, raising the x to the fourth power, so on and so forth. Okay, so you just have to clean that up. But right now, okay, I will let you leave it right